and you. This is Helen Thomas and the CDFM study group. You got to get excited when you get ready to study the CDFM because the material can be boring. But if this is your goal, CDF certified like moi, then you got to study and you got to dive into the information. So you got to might as well make it fun as you're going through it. All right, so today we're going to be going over CDFM Module 4, Competency 2, Systems Engineering. So that's kind of continuing the process of developing the capability necessary to meet the capability gap identified in the initial capabilities document created by the JROC, Joint Requirements Oversight Council, and the vice chairman of the Joint Chief of Staff is in the chairman of the JROC, right? So I'm kind of recapping some of the things we learned in the other CDFM modules. And so systems engineering, the word engineering lets you know it's very detailed. Now we're going to be looking at the technical specifications of what it is that we're trying to build. For instance, we're building an aircraft, right? And so we're going to be looking at the systems engineering and how we do that and what that process looks like. You're going to be looking at some of the considerations that you think about as you're developing this aircraft. All right, so we're in 4.2, systems engineering. All right, so on page 422, the definition is there for systems engineering. A lot of the module 4 competencies is information you need to learn. There's not a lot of calculation in this module, except I think module 4.3, the resource management part of it. When you get to earned value management, EVM, that's a lot of formulas and calculations, and we'll get you there. So make sure you know the definitions of systems engineering. It is the overarching process that a program team applies to transition from the capability need that we started off with in JSIDS. We identify we had a capability gap and we have a need. And so from that identification, so actually getting an operational system is the systems engineering process. Let's see, I don't have anything else. The program manager is the single point of responsibility and accountability. Every program has a program manager. Every equipment, if they're building aircraft, there's a program manager for different portions of that process. So for module 4, when in doubt and you don't know who did do a process, you might want to pick program manager because 9 times out of 10, that's the answer. All right, page 423. So in module 4, if you remember in module 2.2, cost and economic analysis, there was a portion where you looked at the acquisition phase. You looked at the phases, you looked at the milestones. So now module 4 is capitalizing on that information and it's looking at the details involved in that process. So when we're talking about systems engineering, again, our manager has the responsibility for coming up with a plan. So before they even go into building the system, they need to know what the plan is. What's the starting point? So that's where your program managers come in. So the second paragraph on page 423 says it. Program managers prepare a SEP, systems engineering plan. You got to have a plan before you start the process. For each milestone review, beginning where? Milestone A. Because on the exam, you may be asked, when does SEP occur and what is it called? And it'll tell you, further continue on page 423. At milestone A, the SEP supports technology development strategy. So in milestone A, you're coming up with the technology development just before the technology phase, right? Remember? After milestone A, technology maturation or technology development. Okay, so it's supporting that. And then when you do another SEP at milestone B, it supports the acquisition strategy. Well, why did the name change? If you recall from module 2, we said that the acquisition program does not begin until milestone B. So that's why it changes to acquisition strategy, because now in milestone B, now we're in a full-fledged acquisition program. Now it's acquisition strategy. So when is the SEP done? Systems engineering plan is done at milestone A to support technology development, and it's done at milestone B to support acquisition strategy. So both of those strategies. All right, what do we got back here? You look at technology review. So these are all the things that are done before you actually start developing the item. Configuration management, what does that look like? You think about hazardous safety concerns, occupational health, the environment, the impact of what you're going to do, all of those considerations. Corrosion, is it going to get rust based on the weather? So how do we prevent it? So corrosion prevention on the top of page 425. Modular open systems approach. Modular open system, because we want to make sure that if I need, just like if you buy a foreign car, 9 times out of 10, you have to go to that foreign car dealer to get the parts to go on your car. When you build these systems and equipment for the military, you want to make sure that you can easily find the parts that you need to maintain and sustain it. So we want an open systems approach, being able to change, adapt, and evolve in the acquisition process. Every equipment have their own, I guess you could say, serial number, but here it's called item unique identification. Like the aircraft have a tail, but basically is their serial number to identify what they are. Electromagnetic spectrum supportability, that's dealing with internet, for lack of a better word, or connectivity. 9 times out of 10, if you have an aircraft, you're going to have the equipment, technology, you're going to have GPS, you're going to have all the knobs in there. So you're going to need to be able to connect. So you want to know, does it sustain it? What type of system are we building, and what capability is it going to need? The next page, integrated product and process development. Understand that it's not one team that's developing the whole aircraft. You got everybody have their own role in what they do in the process. So you have integrated different processes, then you have to integrate them to make sure that when you put all the pieces together, you have the aircraft that meets the support and meets that need for the warfighter. On the last sentence in the first paragraph on page 426, it says, the concept of integrated product and process team development, so it is IPPD, and integrated product team shall be applied throughout the acquisition process to the maximum extent practicable. All it's saying is we need to have these teams be integrated. I mean, think about it in just a common sense type of approach. Is if you have different teams working on my aircraft, somebody's working on the wings, somebody's working on the tail, somebody's working on the body of the aircraft, somebody's working on the inside, somebody's working on the cockpit, and all of that. I need to integrate. So I need to have, and I think this way, yeah, the next page is going to go into the different levels of teams to pull all of it together. So let's go ahead to page 427. So you go into their 3 levels of IPTs, integrated process teams. So I think it's the highest one. So we'll start with working level. So working level are your working bees. So working level integrated product team. Then you have a grading integrated product team, IIPT, and then you have an overarching that pulls all together. So overarching integrated product team. Just learn them the way they are. Don't ask me why. It's an integrated product team. That's just what it is. So let's just work with what we have. All acquisition category, all your major acquisition, 1 delta, defense level, right? The D behind it. And 1A, M, is automated maze at the DoD level, defense level. So all DoD level programs will have an OIPT to provide assistance and oversight, synchronizing efforts. Program manager, whoever they design in collaboration with OSD action officer from the Office of OIPT, should collaborate to form co-leads. So I'm not going to be reading through a lot of these. Only if I have a highlight, then I'll point out, okay, maybe you should read that particular area. WIPITs, the working level groups, the second bullet. So we said the program manager is in charge. The WIPITs are advisory bodies, right? The actual worker bees who's actually working with those, so they'd be able to identify things that if you're sitting up here, you're probably not going to consider. So they work with the program manager to advise them. Direct communication between the program office and all levels in the acquisition oversight and review process is expected. Okay, that's straightforward. Read your summaries at the end of module 4. They help to kind of guide the process. Let's see. The next section of systems engineering, we got some definitions, and definitely not going through each one. So we got technical management processes. So know the difference between if something is a technical management versus a technical process. And I think you can kind of figure those things out. All right, let's see what it says. Decision analysis. So page 11, since I have my little check mark to read this part. Decision analysis. So it says it provides the basis of evaluating the alternatives. Because again, when you come up with what you need, then I need to have different alternatives to get it done. So decision analysis involves selecting the objectives, so the criteria that you need to be able to base your decision on why you pick item number B will be the best fit. So decision analysis, technical planning, technical assessment, how you manage those, requirements management, provides traceability back to the user defined capability. So you got to be able to follow from the capability need. How did we evolve into this aircraft? Does it meet the need? So capability requirements management, configuration management, the same way, audit trail. As they continuously change and make decisions throughout the process, then you document it. And when you deal with acquisition, don't forget the acquisition decision memorandum is being updated. That was mentioned also in module 2. So that's kind of pulling the same information. Other definitions are under technical management, data management, interface on page 13. And then we switch to the technical processes on page 4214. Stakeholder requirements definition. We want to know what are constraints on schedule. When do you actually need the equipment? Technical constraints. What are our focus? Requirements analysis. And they got the definition there. And we need alternatives. So architectural design process is a trade and synthesis process. It translates the output of what the stakeholder requirements definition and requirements analysis process into alternative design solution. So architecture. So all of it is being flexible in that process. Some other definitions under the technical processes, page 4215. Implementation. When I'm studying, I always look for words such as implementation is a process that actually yields the lowest level system elements in the system hierarchy. Lowest, largest, highest, first, last. So those are the kind of words you look for. So implementation. Know the definition. Then between verification and validation, you need to know the definition. Verification said, did I build this aircraft correctly? I'm verifying that I build the aircraft correctly. Validation is saying, does it solve the problem? Is it the right solution to fix the capability need? So validate that it meets the capability need. Is it the right solution? Verify that you built the aircraft correctly. Is it the right? Did you build it correctly? So know the difference. Basically, I'm saying know the difference between verification and validation. All right, so that's it for that one. Let's see. Oh, no. Page 4216. I had it on my exam way back when, and I do have people be like, hey, you need to focus on this particular area in your study group. So there are two definitions you need to know on page 16. In those two paragraphs, you see the words system of systems. And the second paragraph, you'll see the term a family of systems. Watch the difference. So a systems of systems engineering deals with taking different capabilities, putting them together, and when you put them together, you have a greater output. So let me find the words for you. If System of systems engineering deals with planning, analyzing, organizing, and integrating the capabilities of a mix of existing and new systems into a system of systems. I'm taking bits and pieces of different systems to kind of build the capability that I want. But the key thing here with system of systems is having a capability greater than the sum of the individual capability of each part. So if I took each part individually and then I pull them together, when I pull them together, I have a greater capability than each individual part. That's a system of systems. The second paragraph on page 16 references a family of systems. A family of systems says that even when I group the different parts together, and it does not result in a greater capability. That's a family. They just happen to be similar. So let me read what it says. A family of systems does not create capability beyond the additive sum of the individual capabilities. So it doesn't give me any other benefit by using XYZ parts. But the ABC parts, when I put them together, I have a greater capability out of it. And they give an example. For example, each system in a family of systems may belong to the same domain. They may simply be all of these are missiles, a family of missiles or aircraft. Did they give an example on the other one? No. Okay. So that's as deep as you need to get with it. System of systems, a greater capability in the output. Family of systems, they're just family, so they don't give you any greater output. So that's the part I want to make sure I didn't miss. In the acquisition process on page 4217, talks about the evolutionary acquisition process. Meaning, whenever we need and we have a requirement, we don't always want to start from research and development. We don't have that kind of time. Sometimes we need that equipment in the next 2 years, 3 years. I don't have time to start from scratch. So we always look for opportunities to evolve, or evolutionary acquisition means I can look on the commercial side and see that they have a similar aircraft to what I need to build. And I can buy their aircraft, and then I can add the military capabilities to it to be able to meet that capability need versus me going out and building my own aircraft from scratch. That's the evolutionary acquisition process. And they got the summary, and they repeat again the system program manager should ensure that the contractor has established a process. All right, what else? The next part we're going to move to are the phases. Starting on page 19. Remember, it's material solution analysis, because once now we have our courses of actions we're going to analyze. We have our objective, we got our baseline, we know exactly what it is that the program manager has given us a starting point. So material solution analysis is now authorizing entry into the acquisition system at any point because it's evolutionary. And the milestone decision authority has the ability to say, okay, let's go directly to milestone B. We've already have previous data on the material solution. We already know what we want, so we don't have to start from material solution analysis, then go through milestone A, then technology development, and so forth. Page 20 at the bottom, that paragraph. It says, I want to point out something to you. So remember, no, maybe you don't, but let me refresh your memory. When we did the analysis of the alternative in material solution analysis, we said that the DCAPE, Director of Cost Assessment and Program Evaluation, provided guidance on the development of the AOA. In the module 4, the title of the DCAPE was the second to last line. It's the Director of Program Analysis and Evaluation. The DBA and E is the same person as the DCAPE. The DCAPE is the newer title. So if you see it on the exam and you see the DPA and E, that is the same person as if they say who provides the guidance on the AOA or who does the cost analysis for the DOD level. That is your Director of Program Analysis and Evaluation. So that's the same thing. I don't know which one you might see on the exam, because again, I do not see the exams. So I want you to be privy to know that those two are the same. Shall propose study guidance for the AOA. DK provides AOA guidance. And we already learned that in module 2, cost analysis. Continuing with analysis of the alternative on page 4221, the MDA, Milestone Decision Authority, so depending on the level, so now you remember those ACAT 1, Delta, ACAT 1, Charlie, and we said that the US, back then it was the USD, ATNL was in charge and so forth. Now in the newer study guide is the USD for acquisition and sustainment. So keep those in mind, that is the same individuals, just in case they go back and forth. So the MDA approves the AOA, analysis of the alternative. So those are your guidance, your objectives, and so forth, all the criteria that is a starting point for when you get ready to compare different courses of action. The key thing with that first paragraph is to remember that the acquisition decision memorandum is everything is documented in that acquisition decision memorandum. The MDA's decision to begin material solution analysis, going back to your knowledge of an acquisition program, does not begin until a decision is made at milestone B. Bravo. So just because the MDA says, let's do the material solution analysis, we'll meet again in milestone A, then we'll decide if we want to move on to technology. That does not mean that an acquisition program has been initiated. So that's what they're repeating here. The third paragraph mentions some terms you should already be familiar with. The ICD, Initial Capabilities Document. When 3 DoD support system, JSIDS, PPBE, defense acquisition. In JSIDS, they look at the National Defense Strategy. What is defense trying to do? What are our capabilities? What capability gaps do we have? So the Joint Staff is part of the JROC, that they represent the warfighter. So they're doing that in JSIDS. At the end of the JSIDS analysis, the JROC would produce an ICD document to say this is the capability gap and these are our recommended solution. So the ICD and the AOA study guidance shall guide that material solution analysis phase. The AOA focuses on identification, analysis of the alternative, measures of efficiency and effectiveness, schedule, so all the key things in that process, and of course, overall risk, because there's a risk associated with every decision that we make. The last paragraph on page 4221, material solution analysis ends when the AOA is completed and you have a capability suggestion or recommendation. So material solution options for the capability need identified in the approved ICD have been recommended to the milestone decision authority and by the lead component. And the phase specific interests, because remember your joint staff has representative from each component on it. So depending on whatever the solution, the Army's like, okay, this is a recommended Army solution. So they provide the capability. And this is done at milestone A. Because after material solution analysis, all of that finding is then reported at milestone A, which is a decision point where they can make a decision on moving on to the next phase on page 22, which is technology development. Make sure that you associate technology development in module 4 to technology maturation and risk reduction in module 2. It's the same thing. The older term was just technology development, even though it included risk, but it was just technology development phase. But the newer term is technology maturation and risk reduction. The purpose of the phase is to determine how to reduce technology risk, determine the mature and mature the appropriate set of technology. So it's all about focusing on the technology. How do you enhance the technology, reduce risk, demonstrate critical technologies on the prototype? So we have a prototype, we added technologies to it. How does it work? How does it operate? On page 23 at the top, so at milestone A, the MDA reviews the material solution analysis. Just remember that flow. And then they draft the technology development strategy. Because before we go into the technology development process or phase, we need to have a strategy and how we're going to do that. And so again, the acquisition decision memorandum document is updated throughout the process. It is important to realize that before milestone B, the acquisition strategy must be written. So before you enter the next phase, there's a strategy that's done before you get to that phase. That's basically all they're saying. So if you think of it in that concept, always understand it's not just milestone A, we just jump right into the next phase, technology. We have a technology strategy, development strategy. And then, so then you know, what is it called in milestone B? Acquisition strategy. Because when we started in the beginning, we said the SEP supports technology development strategy. Another SEP at milestone B supports acquisition strategy. Don't forget that piece, because you got to tie all of that back together. I don't know if I have it there, but I have the little at the diagram in the middle of page 23, the exit. Let's see what it says. Affordable increments of military useful capability identified. So when you exit that phase, is you want to have an affordable increment of technology capability identified. Technology demonstrated in relevant environment, meaning if I'm going to take it into an area that's cold, I've tested it in that area and so forth. So when you exit, meaning you have a solution that meets that need. On page 24, second paragraph, At milestone A, the DoD component shall submit a cost estimate for the proposed solution identified by the AOA. So just picture in material solution analysis, they're doing the analysis of the alternative. Okay, let's look at option A, B, and C. Based on after evaluating all the criterias, the objectives, and all of that, and we say, let's go with option B. And we also want to know the bottom line. How much is it going to cost? Because that's what everything boils down to, is money. I don't have anything on the next couple of pages before we move on to, let's see, at milestone B, page 26. So always look at the little, I guess you could say those were like slides for those pages, because on the exam, you're going to need to know what happens at milestone material solution analysis, milestone A, technology, milestone B, engineer, manufacturing. You're going to need to know what is happening at those. And so usually on the little, I don't know if you can see it, like the little diagrams, such as on page 4226, it says at milestone B, the MDA approves program initiation, entry into the EMD, which is the next phase, the acquisition strategy, acquisition program baseline, that's that cost now, because we looked at the technology, we look at the options, we got a cost from the program manager, so that's approved in milestone B. The LRIP, so even without me going through the slides or the pages, I can get it from this one slide. The low rate initial production, meaning if I need 1,000 aircraft, I'm not going to build 1,000 aircraft initially. The LRIP is the lowest amount of that aircraft that we decide that we're going to build up front. So let's say we're going to build 10. So the LRIP is 10. So that's identified. That quantity is identified. Exit criteria to the next phase is identified. What type of contract? Milestone B certification, 10 U.S. Code 2366, and the acquisition decision memorandum. So these are good snapshot if you're writing your own notes or whatever, however you're studying, is what's happening at milestone. And I also recommend, if you have a blank sheet of paper as you're going through these pages, okay, this happened at milestone A. Acquisition strategy happened here, milestone B, and then so forth and so forth, to help you to keep track, because you can visualize it better on an exam if you write it out, not just try to memorize it. Just, it works for me, and for a lot of people said they've tried it and it worked that way. So after milestone B, you have engineering and manufacturing. Once the decision is made, you come to the EMD phase. Again, it also tells you enter, mature technology approved, and so forth. So I'm not going to read through that. The top of page 28 gives you the purpose. So with all of these phases, you need to know the purpose. And the key thing that comes to me with a lot of these is cost, schedule, performance. Cost, how much things cost, I want to know. Schedule, how long is it going to take for them to do the work? And performance, what's the quality of the work? Because not everybody do the same type of work as we go through the process. So the purpose of EMD is to develop the system. Now we come up with all the idea, we build prototypes. Now we need to actually initiate that process. So what you will see, several things at the EMD phase. The capabilities development document, acquisition strategy, the SEP, remember we learned that, and acquisition strategy, and also the test and evaluation master plan, the TEMP, shall guide this process. So those are all key terms that are identified in the EMD phase. And let me see. I think they're going to say it a little later, but it doesn't hurt if I say it. Yeah, it's like on page 31, what I'm thinking. So all right. EMD begins at milestone B which is normally the initiation of an acquisition program. That's bolded on page 28. So remember, when we read off what happens at milestone B, we says that the program manager does the acquisition program baseline, and the acquisition program baseline is approved at milestone Bravo. Page 29, second paragraph, EMD has two major efforts, engineering, manufacturing, development. Two efforts are integrated system design and system capability and manufacturing process. Know the two. So integrated system design, it tells you, okay, we need to be able to, the effort is intended to define systems of systems. Remember, we get more of a capability when we do the systems of systems, functionality, and interfaces, complete hardware and software, detailed design, and blah, blah, blah. Sorry about that. Not reading all of that. What I wanted to get to on page 31 is, remember we said at milestone B, the LRIP quantity was identified. Well, now that we're in the EMD phase at milestone B, we identified the number, and in EMD phase, we're actually going to develop that 10 aircraft that we said was the LRIP. So the LRIP quantity shall be included in the first selected acquisition report after its determination. So we have developmental tests. So I think, if I remember correctly, on my exam way back when, they asked when does testing occur in the process? Testing occurs throughout, because they're not going to wait to develop the item. If you think about it, develop the item completely or develop that aircraft completely to then test it. So depending on where they are in a stage, they can test it to see if it meets. Okay, check. Move on to the next. A repetitive sentence on page 7, number 7 on page 31 at the bottom. For milestone B, the PM prepares, the MDA approves an acquisition strategy. So we said the LRIP, the acquisition strategy, capabilities, development document, all of that at milestone B, and we actually developed the LRIP in EMD. And then we come to milestone C, which, let's see. So LRIPs identify. Production and deployment begins on the bottom, page 33. And it talks about the purpose. When do you enter it? The purpose of that production and deployment. So I think, let me see, I think I said something incorrectly. Yeah, because the LRIP is production and deployment. All right, so production and deployment 4235, low rate initial production. So I misspoke earlier when I said EMD, engineering and manufacturing. So the effort is intended to result in completion of manufacturing development in order to ensure adequate and sufficient manufacturing capability to produce the minimum quantity. So LRIP is actually done in production and deployment, that first part of that phase, because you don't move on to full rate until we have another decision point after we begin production of that LRIP. So to develop production and deployment, you develop that 10, and then on page 36, you have a decision point. If you look at the diagram of the phases and the milestone, full rate is not considered a phase, or it's not a milestone. It is a decision point, such as milestone A, B, and C are decision points. Full rate production and deployment is also a decision point. That's when they look at the results of us deploying those 10 aircraft to determine if we need to move to full rate and develop the additional aircraft. So that's more full rate On page 37, it mentions military equipment valuation for milestone C. The program manager prepares a program description as part of the acquisition strategy. And I think in module 2, it's called the CARD, if I'm not mistaken. CARD is the acronym, right? Yeah, I have to go back and look, but I think that's what it's mentioned. But again, module 4, so you got to stay with the material that's here. Program description is done at milestone C. It's done by the program manager. So the DoD component to another component are updated quarterly throughout the life cycle. So remember, it's the life cycle of that program, from identifying the need, selecting a capability. Once the capability is initiated, then you have a life cycle of that equipment before you get rid of the equipment. So the program manager on the top of page 38 must also have a plan, a life cycle support plan. In order, let's say the aircraft has a 10-year lifespan, then the program manager have to come up with the support for those 10 years and how to keep that aircraft running safely for our warfighters. Operations and support phase. And once that aircraft life cycle has ended, there's always a disposal plan that's in place. So under Title 42 U.S. Code, it provides the disposal plan for these equipment and how you demilitarize. Oh, I actually got it the first time. Demilitarize the aircraft, for instance. Because oftentimes they don't just throw them in the trash. They take the military pieces of it, the military specific pieces of it, and they may sell it. If not stateside, they'll sell it to one of our allied nations. So let's look at some important design. None of this I'm going to read through, because most of it is pretty straightforward. So some design considerations as we're building our aircraft. On page 43, we talk about open systems, because we want to make sure it uses widely supported parts and so forth, interfaces, so we can quickly get what the part that we need, and is building the systems engineering plan. We have software considerations, interoperability, and standardization, right? Because if we got to have standards, we don't want to build 1,000 aircraft and they all look different. So we develop a standard. We also want to look on page 45, commercial off-the-shelf item. As I mentioned, we don't want to always have to go to research and development to determine if to fill our capability gap, if the commercial side already has some type of capability we can tap into. So commercial off-the-shelf, the cost, is a consideration in that process. Is it something on the commercial side that we can tap into to speed up the process? We also consider on page 47 some important design considerations. The RAM, reliability. We're looking at work without critical failure. We want to make sure it's reliable, that it's not gonna, the wings aren't gonna fly off of the aircraft, right? Okay, we don't want that. Readiness, availability. How available is that aircraft? Readiness. And maintainability. What is the ease of maintaining it, supporting it? Do we only have certain people who can work on it, or do we have a lot of support we can get? So the program manager establishes the RAM. Surprise, surprise, surprise. Okay. And then they talk about each one in that paragraph. Supportability again. Human systems engineering on page 48. It simply means now I build the aircraft, and if I put a human being in it, what are the considerations? Temperature, oxygen, all of these human related things to keep our warfighters safe. So human integration. Safety considerations on page 49. Environment, safety, occupational health, survivability. If that aircraft is attacked, what is the ratio of survival of our war fighters? Susceptibility. These are all your considerations. And corrosion prevention. We don't want it to get rusty. How do we prevent it from getting rusty? Being in different types of weather. So those are the different considerations. We also look at page 51 on what is the disposal plan, demilitarization. So this is kind of repetitive of what we talked about a few seconds ago, really. So during systems engineering, as part of the program manager's total life cycle systems management, the program manager must consider demilitarization and disposal. So repeat. Information assurance. How do we protect the information? Can we share the information, use of that aircraft with our allies as we train alongside them? Is there certain things that they're not allowed to see? So information assurance, we got to make sure that is considered. And sensitive munitions. Now, what is this? I don't have anything here, but ultimate objective when making design decisions on munition is to develop and field munitions that have no adverse reaction to unplanned stimuli. Meaning, I don't want, if I have the rounds, the ammunition on my aircraft, and if I get a certain height, then the ammunition explodes. So I don't want insensitive, it's funny they picked that word, but insensitive munitions. Anti-tamper and system security. So these make sense, right, of things that you have to consider as we're developing our capability. We need to be able to protect what we have on page 53, a component of overall system security, research, and technology protection. So we have to have safeguards on our technology, our research. Is it something that's specific to the United States military? And how do we make sure it doesn't get into the wrong hands? So safety considerations on our and protection of our research and technology. How accessible? Up to the program manager must ensure that electronic information complies with Section 508 of Rehab Act of 73. We just making sure that we're protecting the equipment, the information to develop the equipment. Item unique identifier, we talked about earlier, that's basically your serial number. To enhance life cycle management of assets and to provide more accurate, the PM shall plan for an implemented item unique identification to identify and track applicable major items. Critical safety items are also considered because some equipment might have something critical that's attached to it that we need to know about. So every detail, every aspect of that development is captured and remembered. All right, page 255 goes into systems engineering tools, techniques, and resources. And here we go again, repetitive, right? 4256, the SEP, Systems Engineering Plan, is a detailed formulation of actions that shall guide all technical aspects of the program. So again, the SEP is done at milestone A to support technology development strategy, and the SEP is done at milestone B for acquisition strategy. That's all it's saying in that first paragraph. The term value engineering means an analysis of the functions of a program, project, system, product, item of or equipment, building, facility, or supply of an executive agency. Sorry, yeah. All right, enough of that. Modeling and simulation. What are you doing? Modeling and simulation is the same thing as testing throughout the program. Remember I stated that? And if you read, let's see, it says that at the top of 58, that modeling and simulation is an essential element of the systems engineering process and can represent. But basically, if you read through all of that, it's telling you that starting at the beginning of the life cycle of that program development, that modeling and simulation occurs throughout the process. And it's that total systems engineering approach. Modeling and simulation occurs throughout. And that's, let's see. Yeah, and so that is all that I have in Module 4, Competency 2, Systems Engineering. And so a lot of this, as you see, the information is repetitive, which is good, because when you're taking these kind of exams, it's the number of times you go over the same information, but you look at it from different angles. You don't look at it as individual parts and like, oh, this is another SEP. No, it's the same SEP they're talking about. And being able to tie the information from module 1, 2, and 3 into 4, and mainly module 2.2, which we touched on cost and economic analysis and the phases and the life cycle support plan and so forth. All right, this concludes module 4.2 for today. This is Helen Thomas. I thank you guys for supporting the CDFM study group. If you have not already, click that subscribe button for me. Click that notification at the top. So every time I upload a new video, you will get a notification that the new video is out there. I try to keep going over the information because every time I go over it, I come from different angles. I learn something new in the process. And so I will continue to do these videos for you. So please subscribe, leave a comment, click like, because I need more activity on the YouTube platform. And that way the YouTube folks will then advertise our channel even more. So this is Helen Thomas and the CDFM study group. I'll see you guys again next time. Thank you for stopping by.